Hi, I'm Parity Sabetti, and welcome to Against All Evens. Today, we are going to explain two sample t-tests. First off, here are some terms you might need to know. Mean, the average of a given sample population. We have population mean and sample mean. Also, standard deviation, a quantity calculated to indicate the extent of deviation for a group as a whole. As well as, you need to know the p-value, which is the probability that the null hypothesis is true, and the test statistic, or the t-score. The equation will be given later on. We also need to know our null hypothesis, which is the hypothesis that there is no significant difference between the mean of specified populations, and the alternative hypothesis that states the hypothesis that there are significant differences between the means of specified populations.
Hi, I'm Gwen Nectarine. I'm a meteorologist conducting research on climate change. We have collected data from 2 different years on the same month, January, to see if it was significantly warmer in 2018 versus 1962.
Okay. We retrieved our data from various weather reports which showed previously recorded weather averages from those days in the LA area.
Yeah. And from this data, we should be able to tell if there's a statistical significant difference between the 2 years.
First, we must check the conditions, such as whether or not the sample is a simple random sample, if it satisfies the large counts condition, and if the sample population makes up 10% of the total population. Now, for this example, our population is 31, as January has 31 days in it. Our null hypothesis is that there is no difference between the 2 years we collected data from, written as mean 1 minus mean 2 equals 0. Our alternative hypothesis is that there is an increase in the average temperature, written as mean 1 minus mean 2, is greater than 0. Mean 1 is from January 2018, and mean 2 is from January 1962. Now we're going to put this information into a graph. On the top scale, our null is represented as 0, and our alternative is represented as 6.678. This number was obtained by subtracting mean 2 from mean 1. Our t-scale is directly below, also with 0 as the null, and 3.329 as the alternative. This value was obtained using the test statistic formula. The formula for the test statistic is the mean of sample 1 minus the mean of sample 2 over the square root of the sample's standard deviation squared divided by the population size of sample 1 plus the sample's standard deviation squared divided by the population size of sample 2. Referring back to the graph, after calculating the test statistic, we were able to find the p-value, which is represented by the shaded portion. And now Madison and Pauline will interpret the data.
And we're back!
So now that we have significant evidence against a null at the significance level of 0.01, if the null were to be true, then results as rarely as 78 out of 10,000 times would occur.
Excellent, Pauline.
Thank you.
And I am now convinced that there was a significant increase in weather averages between the years 1962 and 2018.
I'm Parity Sabetti, and this has been another episode of Against All Evens.